So, continuing this lecture, the first one of the three software design models that we're going to take in this course is the system development life cycle, or it's called sometimes in some books the software development life cycle, SDLC. The development life cycle of a certain software is the process of creating creating the idea of the software, identifying the idea of the software, planning the various phases of the software development and implementation, the actual creating of the code of the software, the actual development of the code of the software, the testing and the deployment and the evaluation of the software. All these steps, they are all included in the software development lifecycle. This model is composed of a group set of phases. Mainly it has 7 distinct phases. Each phase has a unique set of activities. So you can identify in each phase of the 7 phases of the software development lifecycle a unique set of activities, user activities. The 7 phases of this model are: the first phase is called the identifying the problems, the opportunities and the objectives of the software. The second phase is called determining the human information requirements for the software. The third phase is called analyzing the software needs. The fourth phase is designing the recommended software, the process of designing the software, not the implementation of the design. The implementation is done in the fifth step. The fifth phase of the SDLC is called developing and documenting the software. The sixth stage is called testing and maintaining the software. And the seventh and last phase of the SDLC is called implementing and evaluating the software. For each one of the 7 phases, I will explain briefly the various steps, the activities of the phase, and the outcomes of each phase. First, it's very important to state that the software engineer should take into consideration the human-computer interactions between the humans who are going to use the software and the software itself. So this is a layer of the software which is between humans and the devices and the machines that are going to implement and run the software. So the software is executed and implemented and run inside devices. The humans will use these devices. How will be the interface between the humans and these devices? This interface will identify the human-computer interaction. The type of interface that the software engineer designs for a software could play an important role in the success or failure of the software. If you are designing an interface for a software that will be used by expert users, scientific users for example, then you need to take into consideration that these users require sophisticated interface that contains sophisticated buttons, very scientific information inside the interface, and so on. But if you are designing an interface for clients and customers who need help in every and each specific detail of the software, then you need to design a very user-friendly interface, and you need to provide much amount of help as much as possible in the interface. So the type and the structure of the interface of the software is very important according to the requirements that are stated by the users who will use the software. From another point of view, in many cases, the software engineer will gather information from the users at the beginning. What do they expect from the software? What do they need from the software? In this case, the software engineer should should ascertain that he or she has gathered all such required information and identified all the specific needs that the users of the software expect from the software. So if the user expects something and the software engineer doesn't understand fully that thing, then the software might be produced not complete or faulty. So always the users of the software, they remain afraid that the software will be produced and not all the requirements, specific requirements and details of usage of the software are fulfilled in the software. That's why in many cases the users, they require from the software engineer, they require from the software development team to update and produce patches to the software to take into consideration certain aspects that has been neglected in the design and implementation of the software. So let's talk about the 7 different phases of the SDLC. The first phase is identifying problems, opportunities, and objectives. In this phase, the idea of creating a new software has begun, and the requirements of the software need to be identified and documented. So the software engineer is responsible for interviewing the management of the company, for interviewing the employees who work on the software or who will work on the software, is responsible for interviewing the customers or clients who will use the software. From all this gathered information, the software engineer will create a general overview of the software, of the current situation that is implemented, and how the software the intended software will improve this situation. In addition, at this stage, the software engineer is responsible for estimating the scope of the software. So what will be the specific scope of the software? Who will be using the software? Who will be the stakeholders of the software? And what will be the role of each of these stakeholders? After also the software engineer need to document all the data that he gathers and produce feasible results from these documented data. At the end of this stage, the software engineer is required to create something called the feasibility report. So the feasibility report is a study that summarizes the data that was gathered by the software engineer, that identifies the problem that the software is trying to solve, and the software engineer is required to put into action several possible solutions for the problem in the means of one or more software designs. So the software engineer might, for example, consider using a certain built-in software to be used directly. He might consider as another alternative to design and implement the software from scratch, or he might propose another solution to use a combination between a software system and a manual system, for example. All these are called alternatives for solving the problem that the software engineer is trying to solve. So the feasibility report will discuss each one of the solutions and will try to reach a conclusion that prefers one of these solutions. All of these details will be included in the feasibility report, and the software engineer will need to include these details, summarize them, and reach a certain specific result and recommendation of a certain solution. And then the software engineer will send the feasibility report to the higher management of the company so that they can take a decision and send to him to proceed with the project and start implementing, designing the software, or to cancel the project and stop work on it. In some cases, the higher management might send to the software engineer to gather more information, to consider more solutions, and to try to reach a better solution than the one in the feasibility report. Now, after the first phase finishes, according to the feedback from the upper management, if they decide on continuing the project and moving to the next step, then the software engineer can start on determining the human information requirements of the software. Now, in this phase, the software engineer will continue with interviewing the management, the clients, and the customers, and the employees who will be using the software, but will do these interviews at a more specific and detailed level. So he will need to gather more specific information, more detailed information about the software and how it will be used, and the specific objectives of the software. In some cases, the software engineer is required to make surveys, questionnaires, and so on if he is interviewing a vast amount of employees or vast amount of customers, vast number of customers. In this case, it's better to use questionnaires and surveys than to make manual face-to-face interviews. Also, in this phase, the software engineer is required to observe the decision makers' behavior and environment. So the decision makers here meaning the places, the people who will be included in the software. So suppose the software is intended towards a certain type of employees, the software engineer needs to observe the current decision making that is done by these employees in order to reflect this decision making inside the software. So the decision making of the employees who currently perform the operations of the software need to be reflected and reached the same in the designed and implemented software. So generally, the software engineer at this step will need to learn all the details related to software, the who, what, where, when, how, and why of the current system. The current system means the current implemented software or manual operation that is currently replacing this software, and the software engineer need to learn all these steps and how it will improve on them and will perform better than that. So the output of this phase, after this phase finishes, the software engineer should have mastered and understood very well how the software should be accomplished, how it should be done and implemented. Okay. Also, in this phase, the analyst should know the business functions of the company that are done related to this software in order to integrate these business functions into the software that should be implemented. After this phase finishes, the software engineer has now complete overview, complete details about the people who will use the software, about the operations that these people should be doing on the software, and about the current methods in which the software should operate. After this step finishes, the software engineer moves to the next step, in which the software engineer identifies the objectives, the specific objectives of the software. The software engineer will expand the system objectives, meaning it will identify the specific operations of the software in detail, what each operation should be done in detail. So here the software engineer will start the process of designing the software. He or she will start to create the data flow, the activity, and the sequence diagrams. Also, the software engineer will create the data dictionary, which includes all data information related to the software. All data that has been gathered in the previous two phases, in addition to the created initial design, will be put into the data dictionary. The data dictionary will continue until the end of the SDLC, and it will be a repository that will contain all information and data related to that project. Here, the software engineer will identify the alternatives and the decision modes in the software. So, the software engineer will identify at this phase the operations of the software and how these operations will branch according to the specific events that could occur inside the software. After this step, the software engineer will prepare and present something called the system proposal or the project proposal. This will be a document that will contain all the details that has been gathered so far, in addition to the initial design of the software, which will contain the data flow diagrams, the sequence diagrams, and the activity diagrams. These will constitute the initial design of the software, in addition to all the data that has been gathered so far about the project, about the software. Now, according to this data, the software engineer should be able to identify the benefits that the software will offer to the company. So, the software engineer could do the cost benefit by himself, or could make use of the project manager. He could collaborate with the project manager to write down the cost-benefit analysis of the software and the alternatives of implementation of the software, and will put all of that in the system proposal. Then he will, the software engineer will make a certain recommendation according to the analysis that he has made, either to continue with the project with the software if it has been proved that it will provide very good benefits to the company, or to stop the project or to update the project. The software engineer will send the project proposal to the upper management, and they are responsible to giving him the green light to continue with the process of designing and implementing the project, the software, or stopping the software at this stage. Notice that at this stage, the software engineer hasn't actually implemented anything. All that he has done is gathering information and doing a preliminary or a general design of the software. Now, if he gets an approval on the project proposal, on the software proposal, then he or she can move to the next step and start the process of designing the software. In the design phase, the software engineer designs the procedures for data entry, which is the interface between the classes of the software and the users who will enter data to the software. This interface is designed only, not implemented at this stage. Also, all the part of the interface of the software, the human-computer interface, for example, the forms, the audio interfaces, anything related to the interface between the code of the software and the users will be designed at this stage. Notice that we are only doing design here. We are not doing any implementation, any writing of the code, just design. All of these are design steps. Also, the design of the database or the file system that will be used is done at this stage. And finally, the software engineer is required to design backup procedures at this stage. When we combine all these designs together, when we combine the design of the software, the design of the classes, how they will be gathered into packages, what type of interactions and relationship will be between the different classes and different packages of the software, what will be the user interface, how will be the user interface, how the users will interact with the software, what are the details of the database, how we are going to back up the software. When the software engineer finishes all these designs on paper, then a complete model of the actual system will have been generated. Now, when this model is complete, now the software engineer can actually start implementing the software. So the fifth stage, the fifth phase of the SDLC is the process of developing the code of the software and making documentation about the software at the same time. So on this stage, the system analyst or the software engineer will work with the programmers and the developers to develop any part of the original software that should be used in the software. If the software is completely original, then all the software will be developed by the programmers of the company. Sometimes the software engineer decides that he needs to implement a part of the code of the software from an open source project, or will be using the open source project completely to inside the software. In this case, you need only to focus on the original code that you want to write and how to integrate the code that you want to use inside your original code. While the programmers are writing the code and designing and testing, the software engineer is responsible also for working with other programmers to document the steps of the design and implementation of the process. So when you test, when you write any code, you write a documentation of the code. When you test the code, if the code produces errors and you solve the errors, also you write a documentation of the errors that were produced and the solution that you implemented. At the end of the implementation phase, of the development phase, you might be required to develop other types of documentations, such as frequently asked questions on the website, or manual, user manual for the software, or any other type of documentation as required by the company. So the output of this phase will be the computer programs, the code, the various code of the various classes of the various packages of the software, and at the same time the required documentation of the software in form of user manuals, user guides, frequently asked questions, and so on. All of these are produced in this step of the implementation of the software. The next step, when this step finishes successfully, the next step is to test and maintain the software. Now, when you finish designing and implementing the various parts of the software, you need to test them. Usually, testing is done in prototyping. So you take a part of the software, you test it separately. Then you take another part, test it separately. Then you combine these parts together and test them together. Then you add a third part, you test a third part. If it works successfully, you add it to the first two parts and test them together, and so on. So you design your software into pieces, you test each piece alone, then you combine several pieces together and test them. In this way, you can identify errors much more easily, you can correct these errors much more easily, and you can maintain the system after that much more easily. So what you are doing here is that you are testing the system part by part, then you are combining the parts and testing them together. Finally, when you reach the whole system, you test the whole system altogether. While you are testing, you might face errors. So you need to maintain the system by correcting these errors and then doing the testing again. While you are doing this, you need to be documenting what you are doing. You need to be documenting the tests and documenting the maintenance that you have done on the code of the software. So the output of this phase will be the results of the tests, any problems that you have faced, any errors that you have corrected, the updated programs. So these should be programs that do not contain errors, that do not produce errors, and the documentation of the tests and the maintenance that you have done. In the final stage, after you finish all this stuff, it's time to actually deploy and start using the software. Before you could do that, you need to train the users to be able to use the software. Training the users is a very tricky step because you need to know what is the best way to introduce the software to the users and to make them be able to use the software successfully. The next step is to, after you have trained user, you need to start implementing, deploying the software. Usually, when you deploy a software, you don't deploy it as a whole. You don't deploy it in a single step. What you do is that if you are using an old system, you start shifting gradually from the old system to the new system step by step. So you stop some operations of the old system and replace them with operations in the new system. So you start turning on only some of the operations of the new system and at the same time turning off the same operations in the old system. Then when these operations are implemented and are tested successfully that they are working very well, you expand and start using new operations, new activities, functionalities in the new software, and so on until you are able to use the complete new software altogether successfully without any problems or errors. In this way, you have moved smoothly step by step from the old system to the new system. While you are doing this, you need to continuously evaluate the performance of the new software. You need to see if the new software is performing as you are expected and doing the things that you expect the software to do and within the performance limits that you expect. If you have delay limit on certain operations, you need to test that these delay limits are actually met and fulfilled by the new software. So you produce performance reports and performance results from your evaluation of the software. Now, according to this evaluation and the performance result, you might find that some aspects of the process need to be updated. So in this case, you need to, in some cases, you need to stop the deployment of the software, and then you go back to the design phase in order to design new operations that are added to the design of the software in order to make it meet and fulfill the requirements that still it hasn't fulfilled. If the software is working well and all requirements are met, then you continue monitoring the software for a certain amount of time to make sure that it is working properly and correctly from now on. So don't forget that these 7 phases, they constitute the different phases of the software development lifecycle, SDS. This is a model that is universally well known for developing, testing, implementing, and monitoring and evaluating a certain software. Another types of models exist. We will be seeing in the next lectures and in the next chapters the agile model and the object-oriented model. They have different phases and different types of activities that are done in each of the phases. Now, before we finish this lecture, let's highlight an important fact related to software development. When you start creating the software at the beginning, the amount of resources that you are putting into the software will be very, very small at the beginning. What we mean here by resources, we mean time and money. So the amount of effort, amount of time you are dedicating to the software, and amount of finance and budget you are putting into the software. So at the beginning, this is the time axis of the time, starting from the time you develop the software until you implement and deploy you install the software and start using it. At the beginning, you are putting a very small amount of effort, time, and budget into the project. Once you start progressing into the phases of the SDLC, you start putting more time, more effort, and more money into the project. This keeps increasing exponentially until you reach the time you want to install the software. So before that, here at this phase, you are training the employees, you are testing, you are putting huge amount of effort and budget into the software. You are purchasing the required hardware, required software, and you are grouping all that together. At the installment date, you install the software. You make sure that the operations of the software are being performed correctly and as you expect them. So after that, the amount of efforts and budget you start putting into the project after the installment date starts to decrease, because from this point on, you don't require much budget to the project. The amount of budget will decrease. You have purchased everything here. You have met the requirements, hardware, software requirements here. So the budget will decrease. Also, the amount of efforts you are putting into the project also will decrease. So it will keep decreasing by time, because at this step you might require some maintenance to the project, to the software. As time goes on, the amount of maintenance decreases. The software will require less and less maintenance. There is a certain time when the software is completely stable. Completely stable meaning that the software requires no more changes at all. At this time, you don't need to put any effort, any budget or effort into that software. Now, after the stabilization of the project, after a certain time, you might expect that the company will require new needs. The operations of the company start to change. The customers of the company start to require new things from the software. At this step, you need to continuously update the software. You need to continuously do changes and updates to the software. So you are putting, now you are again putting budget and resources into the project once again. This will continue increasing until you reach a certain point here. The cost of updating the project will be higher than the cost of implementing a new software. So at this point, it will be better for the company to produce a new software than keep updating the current software. So at this stage, we return again to the initial stage in which we create a new software and we will start a new software development lifecycle. So with that, we finish what is required for this lecture. Next time, I will start by talking about the importance of maintenance of software. Then I will start talking about the computer-aided software engineering tools or the case tools. Until then, thank you.